Okay, hi, my name is Muhammad Azhar. I'll be describing and explaining more about the design concept for the mini project for cloud services. And then here are the contents that we're going to go through from the architecture point of view, and then what services are deployed, and then from a networking point of view, and then what are the firewalls or 3D group that actually enable things to pass through and being denied. And then the server itself is EC2, and what other services being used out of AWS services that we integrate into the picture, like load balancer and auto scaling. Okay, we go through the requirement. The requirement, first of all, is to actually host a simple web server in a private subnet, load balanced by an application load balancer, and scale using auto scaling group. More into the details of it, we are going to run two EC2 at all time to provide the redundancy and HA, high availability here. And then yeah, so basically that's what the project. Okay, so here are the network portion of it. We are using AWS Cloud in the US is one region, and we have a VPC here, and then hosting in EZA and EZB, two public subnet and two private subnet, and then we already attach internet gateway for the VPC to get internet and NET gateway to let the private subnet be able to be accessible and access the internet. Okay, this is the IP configuration, and then as mentioned, our 2EC2 instance will be hosted in the private subnet, protected or attached with a security group for HTTP, and then load balancer to distribute the traffic in between these two instances, and then to be auto scale according to traffic, high traffic or low traffic with auto scaling group. So if we actually require more, it will spin up more and more instance, and then if the traffic goes lower, it will be spinning in back into the desired state, which is to instance. Okay, so next, just a brief introduction to what the services that has been deployed. EC2, just basically a virtual server in cloud provided by AWS, and then ALB is a layer 7 load balancer, which we are using as we are load balancing an application website which is in the application layer 7, and then the VPC is where everything is housed, like IPs and then subnets and route tables and network gateway. Okay, here are the VPC and subnets created, two public subnets and two private subnets in the US East one. We can see here, and then the next thing that we're going to be asking is how the subnets able to communicate with each other. It's through the route table that we configured. Two public subnets associated with the public route table, and two private subnet associated with the private route table. Okay, looking deeper into the route table, each of the configuration in the private and public route tables. The private route table will route the private subnet towards the NET gateway at the NET, which is an network address station, in order for it to communicate and access the internet, and the local route to go within the VPC itself, in between all the subnets. And for public, it's routing towards the internet gateway for it to access and be accessible, and the local VPC route. Okay, here are the overview of it. You can see as what been explained just now. And then in terms of security group, here the most important one will be the HTTP. This SD web server security group has been configured for the load balancer and the web server, both of them to be configured with port 80, so that HTTP protocol traffic can access to the web server that is in the private subnet through the load balancer. And then HTTPS is just some addition that we can later on configure to have SSL attached to it and be able to browse through HTTPS connection, which is more secure. And then SSH22 port 22 is just to access the server using SSH protocol. That is for the purpose if we want to access and configure inside the server itself. Okay, so for the outbound, we've enabled all traffic to pass through to 0.0.0.0/0, which is the internet. This was configured just to enable the server and the load balancer to go anywhere, to get through all traffic outwards. But for the best practices, probably we've configure more granular and more specific configuration in the future. And then for EC2 instance, basically I indicate here a number of instances here, one as I only configured one EC2 instance initially, and then created the EC2, and then make an AMI image out of the EC2 instance that has been created, and then configure the image for the auto scaling group. It's using T2 Micro with Amazon Linux OS, and been configured to use this user data, which actually install TCP/PD and get the Maria server, and then you will get the content that will be displayed on the web server website, unzip it, and then restart the TCP/PD. Okay, so next we'll be talking about the load balancer. The load balancer is an external load balancer public facing, which is accessible through the internet. That's why we can access the website. Although our server is in private subnet, we access through the load balancer using the DNS name. And then for load balancer, it's also targeting towards a target group. Because load balancer will target towards the target group that includes the web server in the target group, so that it can monitor and see whether it's healthy or unhealthy. And then when it's unhealthy, probably the specs might, the resources might have been spiked up, and then it requires more instance to be spun up. And then the auto scaling group will spin up more of the servers. Okay, then we have the auto scaling group itself, the important player here that actually do the part to do auto scaling and scalability. The configuration here is simple. It's using the template that's configured from the web server that we created using the Amazon Linux T2 Micro. And the configuration for the auto scaling group itself is using the group size that has been configured to have a desired capacity of 2 instances at all time, and then with a minimum capacity of 2 and maximum capacity of 6. That means that when not the traffic is normal, it should have a desired capacity of 2. That means 2 instances must be running, and it will be at minimum of 2, and it won't decrease to 1 server. And at the max capacity, when the traffic is high, it will jump and spin up to maximum of 6 and won't go higher than 6. And then the configuration is also to spin the EC2s in private subnet in zone A and zone B, the availability zone A and zone B, so that it provides some redundancy and high availability in case that one of the zone goes down. Okay, so that's the end of the slide, and then we'll cover more in the demonstration. Thank you.